Hello everyone, my name is Gurjot and welcome to stage 1 of the retail store data pipeline proof of concept project. If you have not watched the project introduction video, you can find it at the link in the description. In stage 1 of the deployment, we will set up and configure an on-prem ETL pipeline to process the client's existing data. For today's presentation, we will do a quick project recap of the client, their process, and requirements for stage 1. We will then look at the data flow architecture for our deployment, followed by a deployment and live demo of the solution. So for this proof of concept, we will be working with a client in the retail sector. The client is, let's call them the mystery retail company, and they want to implement a data solution to help visualize their current data and data they wish to begin collecting. They are both B2B and B2C facing and have a physical and online footprint. Now that we know a little bit about our client, let's look at their current process. For most part, their current workflow is completely manual. Different stakeholders are responsible for generating reports, transforming the data, and distributing to their colleagues within the organization. This includes people in different departments such as accounting, sales, and inventory management. The client has existing infrastructure, which includes point of sale and inventory control systems, which they will continue to use as it is heavily integrated with their current reporting process. All the data that the client generates is saved and archived on the file system as plain text in CSV or Excel format. The client currently visualizes all data using Excel files. The client's requirements for stage 1 are, it will be an on-prem deployment as we will be using the existing infrastructure. There will be multiple data sources. Different data sources will have different requirements for processing. Data will be saved as Parquet files on the file system, a shared portal to visualize the data, and a quick disaster recovery process. Now that we have our requirements, let's look at the data flow architecture. For this data flow, we will be utilizing the following technologies: Airflow, Spark, Drill, Superset, and Postgres, all deployed on Docker containers. Step 1. File is copied into designated folder. Step 2. Detect new file using iNotify tool script. Step 3. Trigger Airflow DAG using iNotify tool script. Step 4. Airflow DAG triggers Spark submit job. Step 5. Spark outputs as Parquet files to file system. Step 6. Query file system using Drill. Step 7. Visualize data using Superset. One of our requirements was for a quick and easy disaster recovery process. To do so, we will use Dockers with mostly pre-configured containers. For the demo presentation, we will do a deployment using Dockers as well as a live run-through of the solution. For this deployment, we will be using a VM with 4 cores, 16 gigs of RAM, 100 gigs of storage space, running RHEL 8.5, and Docker 20.10.13. Let's get started by cloning the GitHub repository. Let's change into our work directory. Keep in mind when executing all the Docker commands to do it from this folder, since it will reference all the volumes from here. Let's go ahead and start our first container, which will be for Postgres. We'll be just using Airflow as the username, password, and database just to make the deployment simple. However, for production, you will want to have something secure. Once the Postgres container has started running, you can go ahead and launch the Airflow container. Now that the Airflow container is running, we can go ahead and add our admin user and upgrade the database. Once Airflow database has upgraded, you can go ahead and log into the server on port 8080 and you will see Airflow. However, you will notice that the Airflow has a warning. The scheduler does not appear to be running. Due to this, the DAG list will not update. Let's go ahead and start this scheduler. Once the scheduler has started, if you go back to the web page and refresh, you'll notice the error message has disappeared and a DAG has appeared in the list. We can now launch the last two containers for drill and superset. Once the superset container is up and running, we will also need to add a admin account, upgrade the database, and initialize it for the first time. Once you've completed all the deployment, we can confirm that everything is up and running by doing docker ps/a and checking the health of our containers. Now that all the containers have been started, let's go ahead and run through the workflow. The first thing we will need to do is log into Airflow and start our DAG. If you notice, once we log in, it shows that there are 0 active DAGs at the moment. Once we enable our DAG by turning on the button and refresh, we can see that there is now 1 active DAG available. Now that we have confirmed that the DAG is active, we'll go over to Superset and log in. Once we've logged in, let's go ahead and click Data, Databases, and then the database button at the top right. We can add the connection string by selecting the type of database, Apache Drill in our case, and enter the connection string. Once we do a test connection, it should come back with working, and we can add our connection. Once the connection has been added, we can go to the SQL lab and run a SQL query directly to the file system using Apache Drill. We will get an error message as there are no files on the system for us to access. The final step will be to start our iNotify script, as well as initiate the pipeline by copying the files into the incoming folder. Once we've copied the file, they will get queued up since we are using a sequential executor. A sequential executor will run the jobs one after the other. For parallel processing, you should use Yarn or Celery. We can now see that 2 of them were successful and 1 failed. If we go to Airflow and go to our DAG run status under Browse, we can see that there were failures as well as the success and which files and the path and the file type. All this reflects the data we are sending over to the Spark job, which will then execute the code accordingly. And if we check Superset, we can now query the file system and see that the records are now available for us to visualize in any manner. Thank you for taking the time to watch stage 1 of our retail store data pipeline. The next video will be stage 2 of our retail store data pipeline. Stage 2 will consist of the on-prem streaming data pipeline.